Hi, it's Molly here again from Technocamps. You're about to watch the video to accompany the Writing Algorithms and Computer Programs workbook and activities. However, there are three things I'd like you to do before continuing with this video. Number one is to watch the introductory video to the Introduction to Programming Principles activity pack, so you're clear on what these resources are all about. Number two is to watch the Getting Familiar with Block-Based Editors video. This is an essential step because it introduces you to the Scratch, MakeCode for Microbit and LEGO Mindstorms editors. Number three, and finally, is please only continue with this video if you have attempted the activities in the workbook. In computer programming, or anything for that matter, the best way for you to learn is by trying things out and then learning from your own mistakes. So provided you've done all three of those things, we're ready to start. At some point in the Algorithms and Computer Programs workbook, there is a task for you to create and execute a computer program in Scratch using the algorithm flowcharts. The flowchart looks something like this. We have a start, input green flag clicked, output move 10 steps, output say hello for 2 seconds, and then finally a stop. Did you manage to execute this program in Scratch? If you did, that's fantastic, well done you. If you didn't, not to worry, I can show you now and then you'll be able to do the next task without any help from me. The first thing to remember is that writing a computer program is like writing a set of step-by-step instructions a computer can perform. In Scratch, we write our instructions from top to bottom. This means that the computer will perform the instructions that we give it in the same order, starting somewhere at the top here and making its way down to the bottom instruction at the bottom of the screen. The same is true in MakeCode for Microbit. We start our instructions at the top, and these instructions are processed from the top blocks to the bottom blocks. LEGO Mindstorms, however, works a little bit differently. Here, we write our instructions from left to right. So we start our instruction blocks here and end our instruction blocks here. And the program will process these steps in the same order, going from left to right. So let's go back to Scratch. The first step in our program is to have an instruction which has something to do with a green flag being clicked. Can you remember where we'll find a block to trigger a program in Scratch, and which one of these are we going to need? Okay, of course it's the when green flag clicked event block that we are going to need at the start of our program. So we go into events, and here it is, when green flag clicked. So we're going to drag that into our program. Notice that this block has a hat on, so we can't add any other instructions above it. You'll note that in the flowchart provided to you, this step is in an input/output shape. Why do you think that is? Well, you're exactly right. It's because this step requires an input by us. It requires us to click the green flag, and therefore the computer program is sensing data inputted into it from the outside world. The remaining steps are all in the same shapes in the flowchart, but this time for slightly different reasons. Instead of using inputs, the program outputs data or information. What data or information are the remaining steps of the program outputting? Well, let's go through it. The next step in our flowchart is move 10 steps. So let's go back into Scratch. We have our when green flag clicked step. But what are we wanting to move 10 steps? Firstly, the first thing to note is that the move 10 steps block should be in the motion category, just here. This is because it controls movement. As you can see, when we click on the motion category, there are no blocks available to us. And it says here, stage selected, no motion blocks. Can you think why that might be? Well, it's because we haven't added a sprite into our program. If we don't have a sprite in our game or our animation or our story, what exactly are we trying to move? So let's try rectifying this by choosing a sprite. So for my program, I'm going to choose an elephant. And I'm going to choose a nice backdrop for my elephant. Let's choose a wetland. Why not? So you can see that as soon as I added my elephant sprite, all of these motion blocks that we were looking for have become available. So now we have these available to us. Let's try again. You'll notice as well that the event block that we added at the start of this video has also disappeared. That's because the program that I'd started to write here was associated with the backdrop, and it wasn't associated to a sprite. So you can see now that the elephant is selected, so we can recreate this code or this computer program. So let's add back in the when green flag is clicked. And let's go back into our motion blocks category and add a block which says move 10 steps. So we'll drag that one into our program underneath the when green flag clicked. And we'll just minimize that a little bit there. Great. It's really good practice to test your program along the way. It helps you to identify errors, because if your program worked in a previous step but not after adding one more step, then it's probably to do with that latest addition. So what our program is telling us to do is it's saying that we should click the green flag to make our elephant move 10 steps. So let's do exactly that. Each time I click the green flag, the elephant moves 10 steps. So that looks like it's working okay. So the next step to add to the program is say hello for 2 seconds. This means that we want our sprite to say hello for 2 seconds after moving 10 steps. Where will we find the instruction block for that? So if you said that we were going to find that instruction block in the looks category, you'd be exactly right. So if we click into looks, there is a block at the top which says say hello for 2 seconds. And we're going to drag that in underneath the move 10 steps block. And I'm just going to minimize that a little bit so you can see the whole program. And again, let's try it out. So every time I press this green flag, the elephant should first move 10 steps and second say hello for 2 seconds. So I press the green flag, my elephant moves and then says hello, moves and then says hello. So that appears to be working. But imagine if we wanted our elephant to say something different, like Technocamps is great. And we wanted our elephant to say it for a different amount of time, say 5 seconds. How could we change that? Well, we can change it by clicking into these white text boxes. So I can click in here and change the text to say Technocamps is great. And we can change this one to say 5 seconds. So again, I'll just minimize that so you can see a little bit better. There we go. So now, every time I click the green flag, my elephant should move 10 steps and say Technocamps is great for 5 seconds. So let's test it. It moves and says Technocamps is great. Notice though that the speech bubble, Technocamps is great, is a little bit longer in disappearing now. That's because we have a longer time duration here. So I click the green flag, we count 5, 4, 3, 2, 1, and it disappears. So great, we've managed to create and execute this program in Scratch. You can add as many sprites as you want to your computer program. They will be added to your scene, but more importantly to your sprite library in the bottom right hand corner here. So let's try it. So we just go and choose a new sprite. I'm going to choose a bat, and I'm going to have a crab. So now I have an elephant, a bat, and a crab. And you can see that they are listed here in my sprites library. Really important thing to remember when you're creating your stories, games, and animations in Scratch is that you're writing your instructions in the right sprite. And what I mean by that is, for example, our elephant has been instructed by us to, when the green flag is clicked, move 10 steps and say Technocamps is great for 5 seconds. But the bat and the crab haven't been instructed to do anything. You can see that the crab program is blank, and so is the bat program. So if we wanted the bat to do something when the green flag is clicked, we would need to give it some instructions here. So I'm going to go and add my when green flag clicked event, and I'm going to make the bat say something. So let's say, I like chilling upside down. And I want my bat to say that for 2 seconds. And what about the crab? So let's add something for the crab. So we'll say when the green flag is clicked, And again, let's make it say something. So let's make it say, I like moving sideways. And hopefully now, when we click the green flag, the elephant should move 10 steps and say Technocamps is great for 5 seconds. The bat should say I like chilling upside down, and the crab should say I like moving sideways, both of them for 2 seconds. So let's test our program. So we're going to hit the green flag, and you can see that they all have their messages. Okay, so things have changed a little bit in my Scratch program now. We now have a birthday scene, so it's the elephant's birthday, and we want to create a story where the elephant moves towards the cake. So remember, we have this program for the elephant. So every time my elephant moves 10 steps, it says Technocamps is great for 5 seconds. And each time we click that green flag, it does the same thing. Let's just double check. Yes, it does exactly what we've told it to do. But imagine I'm making a story now where I want my elephant to move towards the cake because it's the elephant's birthday cake. So it's a bit annoying having to click the green flag every time to move my elephant towards the cake. Wouldn't it be better if we could click the green flag once and the elephant moved towards the cake? Can you think of something we could do or add to our program to get the elephant to do this? So if you said that we should add a forever block, you'd be exactly right. A forever block repeats a set of instructions over and over again. Well, forever. So where are we going to find a forever block? So in control here, you can see we have a block which says forever. And you can see if we just drag it into our program here, there is a slot inside here where it looks like we can add something. And that's where we're going to add the instruction blocks that we want to be repeated. So I'm just going to release this set of instructions from the when green flag clicked event block and drag them into this forever block. And then we can just slot that back in place. So now what the program is saying that forever it should repeat the blocks which says move 10 steps and say Technocamps is great. So I'm just going to change this text to say something more appropriate, like I love cake. And I'm just going to reduce this to 2 seconds. So let's try it. Let's see whether the elephant moves 10 steps and says I love cake automatically. So yeah, the elephant appears to be moving closer towards the cake, even though we've only clicked the green flag once, which is exactly what we wanted it to do. So we'll just stop this program here for now. One thing that isn't so clear anymore is the order of the steps in our program. So without the forever block, it was clear that the elephant moved 10 steps and then said, I love cake. Moved 10 steps and then said, I love cake. So let's just try that. Moves and then says, I love cake. Moves and then says I love cake. But when we put those instructions into a forever block, it isn't so clear anymore, the order. It looks as if the elephant is saying "I love cake" all of the time, and it isn't going through a sequence of steps. But this isn't entirely true. It's just because this is happening because the program is going through the instructions quicker than the time it's showing "I love cake" on the screen. One way we can change this to make it a little bit clearer is by adding a wait block, which acts like a pause in between our steps. So again, in Control, we have a wait 1 second block, and we can drag that into our program in between these two steps. And let's just reduce that to half a second. So now what should happen is that when we press the green flag, the elephant should move 10 steps, wait half a second before saying "I love cake," and it repeats that over and over forever. So if we just drag our elephant back into the position that we'd like it to start in, when we press the green flag, the elephant moves and then says "I love cake," and so on. I'm just going to stop that. So what that wait block is doing is forcing the program to pause for the time specified. Now it's much clearer that the elephant moves 10 steps, pauses for half a second, and then says "I love cake." You should have completed a second flowchart for a computer program in your workbooks. Can you now go into Scratch and execute that second example by yourselves? After you've completed that second example, why don't you start writing your own computer programs? What would you like to do in Scratch? Would you like to create a story, an animation, or make a game to challenge your friends? There are lots of useful resources online to help you get started or to give you some inspiration for your next project, such as Scratch Wiki. This is a really good resource for finding out some more information on some fundamental principles in the Scratch block-based editor. You'll find lots and lots of information on there. You could also go onto the scratch.mit.edu homepage, and from here you'll find getting started tutorial videos, activity guides, so you can explore projects that other people have done and uploaded to the site. You can get lots of ideas about what your next project is going to be. They also have some cool cards that you can access with mini challenges that you can work your way through to build up your knowledge and your understanding of coding in Scratch. You'll find a link to all of these online resources in your workbook. So at some point in the Algorithms and Computer Programs workbook, there is a task for you to create and execute a computer program in MakeCode for Microbit using the Algorithms flowcharts, exactly the same as you've done in Scratch. So the flowchart for the Microbit program looks something like this. So we have start, input button A pressed, output play middle G, output display smiley, and then stop. So did you manage to execute this program in MakeCode for Microbit? I'm going to go through this program now in MakeCode for Microbit, and your task will be to independently execute the second example that you have to complete in your workbooks. So let's get on to the Make Code for Microbit program now. So the first step in our program is to have something in it to do with button A being pressed. Again, just as the first step was in our Scratch program, it's an input-output shape. This time requiring us to press button A to trigger a program. Where will we find an instruction block that requires an input, i.e. for us to click a button in Make Code for Microbit editor? Well, you'll find it in the input blocks just here. And you can see that the first one that comes up is on button A pressed. So let's drag that into our programming window. In Scratch, we started our program with a block which said, when green flag clicked. And in order to execute the program, we click the green flag above the scene. But what are we meant to do here then? One common mistake that I've noticed participants do in workshops is that they click on the A and B keys on the keyboard to trigger the program. But this is incorrect. Remember that we're trying to program the microbit here. So if we click on our virtual microbit, you'll see there's an A button and a B button. So in order to trigger any of the steps that come underneath the when button A is pressed block, we need to click on button A or button B. And you'll notice at the moment that this virtual microbit is greyed out. That's because there are no instructions following on from on button A pressed. So it can't execute a program. So the next step in our flowchart is to add a block to play middle G, which is a music note. Where will we find blocks to play music notes in Make Code for Microbit? Well, it's obvious that it's going to be in this music category. So we'll click into it and have a look. So the first one that comes up is play tone middle C for one beat. So it's not exactly what we want because we want it to play middle G, but I'm confident based on what we learned from Scratch that we'll be able to change the middle C in that white text box. So let's drag it into our program. So where does it need to go? It needs to go into this block here. You can see that there's a space which matches the shape of the block that I'm trying to find a place for. So if I drag it into there and release, then it slots in. So now let's try to change the middle C to a middle G. So if we click in to this text box here, we see that a keyboard comes up and each key on the keyboard has a note associated with it. And if we find middle G there and click, then we were able to change the note. So now we have something which looks more like our flow here. So we have on button A pressed, play middle G. So let's test our program. So let's click into our virtual microbit and we'll click on refresh. And you'll see here now that our microbit has lit up because it now has some instructions to follow on from the on button A pressed block. And when we press this button, the program should play the middle G note. And it works perfectly. So let's minimize that again and look at our program. So the next step is to display a smiley. Remember from the Getting Familiar with Block-Based Editor video, we mentioned that the microbit has 25 LEDs. And let's look at that again. So we have 5, 10, 15, 20, 25. So how are we going to display a smiley on those LEDs? Well, if you remember, we go into this basic category and we can either use the Show LEDs block, or we can use the Show Icon block and choose an LED. So I'm going to take the easy option by choosing the Show Icon block. I could choose the Show LEDs and draw a smiley on the appropriate LEDs. But I'm not going to do that. So I'm going to drag this one into the program under the play tone. And using this down arrow, I'm going to find something that resembles a smiley and click on there. And there we have it. Now, if we press button A, the program should first play middle G for 1 beat and second show a smiley icon. Let's give it a try. So we'll press refresh again, and then when I press button A, it played a tone and then showed a smiley face, which is exactly what we wanted it to do. So we've managed to create and execute our computer program in MakerCode for Microbit. Can you now execute the second example in your workbooks? After you've completed the second program in your workbooks, why don't you start writing your own programs? What would you like your microbit to do? Can you program something that would be useful to you in your everyday life, like a scoreboard, a step counter, or a flashing light for your bike? Similarly to Scratch, there are plenty of online resources that you can use to get started, or if you just want some project ideas. For example, we have 10 awesome beginner projects for the microbit board, and these include some of those that I mentioned just now. So we can create a light up for your bike, or you can create a fitness step counter. And if you go onto the microbit.org/get started website, then you'll find some setting up guides for your microbit and some introductory videos, in addition to some ideas about getting creative and some project ideas. The links to all of these resources are included in. So we've reached the end of our Writing Algorithms and Computer Programs work package now. I hope this video has been useful to you and that you've learned something new. The next work package is on using selection in computer programs, where you'll learn about applying rules, specifically if and else statements to your programs. I hope you'll join me on that video. In the meantime, check out those resources and get programming.